Hello, everybody. Welcome to DePINed Podcast. I'm your host, Tom Trowbridge, and I'm thrilled to have here a co-founder of Fluence, which I'm a co-founder of as well. So my partner, Evgeny. So welcome, Evgeny.
Hey Tom, thanks for having me finally here.
Finally, we've done 30 episodes and we haven't had Fluence on, which is crazy. So finally, we're doing the obvious episode, I guess I would say. So, I reference Fluence a little bit here and there throughout other episodes, but why don't you just tell people quickly, what is Fluence? What does Fluence do?
Yeah, we call Fluence as a cloudless computing platform, which basically means it's a alternative to big cloud providers. It's a decentralized platform that aggregates computing power from a variety of sources and providers globally and packages it into cloud services and offers to developers and businesses to use. So it's a new alternative of current traditional centralized cloud companies.
Great. And help for people that don't understand what cloud services are, maybe back up a little bit and explain what that is. I mean, a lot of DePIN is like mapping of roads, which is easy to understand, or antennas for cellular coverage or for planes, which had wing bits on. So make it a little more specific about what compute is and how important it is kind of in the world overall.
Yeah, well, cloud right now actually powers the whole internet. So the way how internet evolved and became like a huge part of our lives, cloud became sort of the backbone of the internet. It's basically, you know, um, some people call the cloud that it's a computer somewhere that is, not your computer, some other else computer. But basically, there are big companies like Google, Amazon, Microsoft, who built huge data centers across the globe, like thousands of them, and put a lot of servers in it. And these servers, they handle basically the databases, the applications, web applications, backends of mobile applications. They do scientific computations. They training machine learning models, like all these AI, new LLM models being trained basically in the cloud or its alternative. So think about big data centers globally in the world powering almost literally any digital services you are using in your everyday life. And that's essentially the cloud. And then, these companies, if you look at the market right now, big companies, Amazon, Google, and Microsoft, basically owning more than 70% of this offering of this compute resources that power the internet and provide it to the internet. And that's sort of the main issue and centralization issue and threat, and vulnerability for humanity overall is dependence on a very small amount of huge corporations that controlling the really like super important infrastructure for the whole humanity. Yeah.
I mean, and so the way to sort of emphasize a piece of that, this happens when it works, you don't even know it exists because you just take for granted that you open up your phone, it works, that you make a reservation on an airline, that it finds the ticket, that everything is kind of working behind the scenes in the cloud. And that is it has allowed a lot of services and us a lot of efficiencies that we all take for granted. But this comes at some cost, right? And so the cloud cost is this, which comes from the centralization component where they have higher prices. Well, why don't you talk about some of the challenges of the oligopoly and kind of how that is problematic?
Actually, like even this app that we are using to record this podcast is also cloud-based, right? So the video gets streamed from my computer to the cloud, and then your video gets streamed to your computer to the cloud. It's being processed there. It's being like a recoded, like decoded, right? In order to be then published in YouTube and in other channels. So like we're literally dependent on these resources for like almost any digital use case. And so the problem, one of the biggest problem with this dependency is, vendor lock-in. Like a lot of people and companies, especially, um, understand this as a risk. Sort of when you use the cloud, they provide you a lot of services. Like Amazon, they have like more than 100 cloud services, and then you have some pure compute, which is the most kind of universal thing. But then on top of it, you have, you want to have sort of, they call it managed services, like managed pieces of infrastructure that sort of reduce your effort on using and maintaining your applications, like managed databases. They have this like a serverless products of like a scalable computing. They have basically Lego blocks. They provide you Lego blocks from which you can build your system, your complex system. And this sort of these systems that power applications, even this one, they are like very complex. They actually consist of many, many different blocks and databases, data processing, data pipelines, the way how these applications, like multi-modular applications, and a lot of dependencies, events, fault tolerance, all of this involved. So they provide you these Lego blocks. And then when you start using these Lego blocks, you start using them more and more because you want to architect your like more and more complex system. And in this, when you're in it already, you realize that actually now you really using their proprietary software, using their proprietary tools. You rely on like their systems, their like interfaces, everything. And if they want to charge you twice more, you cannot do much with it, because actually the cost of getting out of the cloud is very high, because you already invested a lot of time and resources in building this thing inside of the cloud and using their services. Now, if you want to switch, you kind of captured, you limited. And that's a very rational business strategy for the clouds, and every one of them do it. They all do a lot of services, like even emerging clouds like Alibaba Cloud and others, um, besides top three. They all trying to build as many services as possible to lock you in and keep you paying and staying within their infrastructure. And this vendor lock-in is a big risk, because now your business dependent on this particular partner. Your business is not really independent anymore. And most of these companies actually are US corporations. So now you exposing you may be like international business to US government in these decisions, and to Amazon or Google as a companies and their their management decisions. You also exposing yourself to risks of their teams managing the infrastructure and making mistakes in software and so on and so forth. But these sort of governance issues and these control issues are really dangerous, because any new policy from the government goes out, a lot of people maybe de-clouded, right, deplatformed. They have this term debanked, when people kicked off from the bank, and on the internet it's sort of deplatforming, when someone decides to ban you on the platform and prevent you from using it. So too much dependence on such platforms is dangerous for businesses overall. And there are a bunch of ways how people trying to deal with it. Um, but it's all kind of in the same category of risk.
Yeah, I guess the way I would also frame it a little bit is that you are in the cloud platform, you are subject to their 60 or 80 page term of service document, which allows them to turn you off for effectively any reason that they choose to do. and that is can be they're private companies, right? So they can just pull a switch, and the problem is, you can any business could potentially decide to stop doing business with somebody else. The problem is that these businesses, your business is 100% dependent on it. If they pull the plug, you have a very difficult time continuing your business. And so that is a real risk. And the other point, which I think you also implied there, is when any business grows above a certain level, inevitably it becomes intertwined with one or more governments. And so that becomes another kind of dimension that one must deal with. And so that's the case. It also mentioned, I guess you this is the other point here, but when you have an open platform, and let's talk about Fluence and how Fluence is different. But Fluence is an open platform, and so when you're not in closed ecosystems, you have the potential for far faster rate of innovation and of productization and of kind of market fit, if you will, of new products and services. And so when there is, not just one provider effectively, right? So that to me is another. There's both, I guess, constraints that the cloud provides in terms of being negative pieces of the cloud, like you're stuck in these ecosystems and you can be turned off and debanked and deplatformed, as we've seen. But the other part is in an open ecosystem, besides saving you from the negative things, there's all the upside of potentially greater innovation because of the open nature of it. Maybe that's worth talking about.
Yeah. So I guess there are two big points why open platforms here help. One point is that essentially we create open and permissionless protocol to any hardware provider to join, right? So now it's not the cloud kind of like there's a proprietary cloud platforms on one side, and here it's more like a neutral protocol. We kind of also call it platform, but it's a wordplay, right? But it's a more open thing where providers can join and contribute their hardware. And now customers can choose, okay, like I can work with this providers, with that providers. I can at the same time work with several providers. If there is some provider says, oh, we don't want to host this customer, that's also okay, because all these providers exist within the same ecosystem, and switching from one to another is super easy. Like it like just a seamless, basically, migrations that can happen all the time. And now, because I'm as a customer building on this open source and open source tools and open platform, I kind of don't have this risk of rebuilding everything from scratch while I'm moving from one cloud to another. And I also can prepare for switching. Like I can do some deploy some replicas, and it's all universal across different providers connected to a network. And another point here is that it's actually very kind of emotional in open source community, is that the cloud itself was built on open source, right? So they initially started from open source tools, open source software. They offered open source databases that were like very popular, like MySQL and MariaDB, MongoDB, and the whole set of them. And they provided these databases, but kind of managed sort of like you have this databases instance with fault tolerance, with scalability. So like you spend less time on maintenance, and people like it because they need to do less work. But then clouds actually earn billions of dollars out of providing these open source databases to like millions of companies. And authors of these databases, like who actually wrote the code and created these products, they got nothing. They got just like zero from these clouds and from these billions of dollars. And that's like really doesn't feel like this is really fair, first of all. And second, we see that this open source, like developers of these open source products, in order to get revenue, they had to sort of either do open core model with like customization of their solutions and sell them to enterprises, or sort of trying to have their own cloud solutions and trying to like provide, like say customers, hey, now you can have this MySQL, hosted MySQL by us, not by Amazon. But people still choose Amazon mainly because there's also other services in there at the same place. So because of convenience. So now open source developers did this huge amount of work, and then they created popular product and they struggle to monetize it. They struggle to, because they need to have some revenue, some income to keep working on this product. And clouds earn billions, but they do not share anything. So this kind of drama of this open source versus cloud world, which also can be solved by open platforms. Like open platforms, like in open platforms, we know basically, we can basically track what kind of open source products being hosted on the network, being used by customers, being deployed to which providers, and we can develop the system where this cloud revenue being shared with open source developers, with like authors of the products. And we don't need it, we're not talking about like taking a huge cut of the cloud, like a sort of the payment to the hardware, right? It could be just 1, 2, 3%, whatever. But if you have really popular product, this essential royalties, like these small royalties, would be like really enough for open source developers to sustain and to keep building and maintain their products. So like this economics of like if you put if we create this open protocol, open platform, we can really drive the monetization of open source and drive the creation of new open source tools built on top of each other, because we have this economic piece here.
I guess there's 2 points I want to get into, but what you're talking about, I think, is how I think of, the next sort of iteration, next stage of Fluence, if you will, where you have an open platform and some of the revenue is shared with kind of the authorized or authenticated authors of these different services. And, as you said, this is not, people aren't going to be buying boats and airplanes and retiring on this, but it's certainly stuff to a very small amount that I think the ethos will be quite powerful for providers to share some of their revenue with that on a verified basis effectively. And I think that certainly makes sense. And what's important about that is that then drives incentives for further innovation in the open source community and further development, which I think will drive which will kind of create the incentive for a wealth of products to be developed on our platform, Fluence platform, or other platforms that kind of work this way. And that's effectively, I think, the only way you can compete with these $100 billion, trillion-dollar companies is if you have some incentive mechanism that drives the whole developer community to work towards a goal. Because otherwise, it seems a daunting task to compete with any of these, multinational, multi-trillion-dollar companies. But if you got the right incentive structure that anyone in the world can participate in, now you've got something pretty powerful and interesting.
Yeah, if you look at the clouds, how much they spend on R&D and developing of new services, it's like billions per year, right? It's very hard to compete by being startup with this. So this actually open approach allows to basically to have community collaborating and building services together and building building on top of other pieces, and we see that this strategy actually working, for example, in blockchain space, right? In blockchain, it's kind of similar, like it's a specific subset of computation, like it's a consensus based, that's why it's limited, that's why it's like deterministic and so on. But it's very open, right? On blockchain, I publish smart contract. Now, if this becomes useful smart contract, and other people consider it useful to integrate in their applications, they can just do calls to this smart contract, right? So now, if this smart contract designed in a way that it shares some of its revenue with those who kind of do the calls, then now you have similar model on blockchain. And we can see, like in DeFi, for example, we have routing smart contract that route liquidity, and then we have some DeFi application that use these routers to optimize, to minimize fees for their customers. And then we have wallets that use DeFi applications that use routers of liquidity. So it's a similarly kind of stack of the software products that being reusing each other openly, like transparently, without any additional like permissions and stuff. And some of them have this also incentive schemas, like revenue share built in. And this is actually what drives them also, their growth. So I think like very similar thing may work with the cloud services, but this open platform is a requirement to make it all work.
And the other point that I think the open platform does, which we haven't talked about yet, is it enables a key advantage of Fluence versus the centralized providers. And that's pricing, right? And so Fluence is whatever 70, 80% cheaper than centralized alternatives. And the question that immediately comes to mind is, how is that possible? How is that sustainable? And it's not through subsidies. It's, again, as you mentioned, this open platform where any customer can switch with almost no friction and certainly no cost to other providers, which means anyone tries to raise prices, the customers can switch to a cheaper provider. If someone comes on that's offering compute at a cheaper price, that's similar level of reliability, you can switch. And when you can switch with no cost, inevitably you're going to compete price down to the lowest possible point. And I think that is enabling. What effectively you do is you help commoditize compute on a global level, which is pretty cool because this is a resource which is globally deployed and for which there is lots of excess in pockets in different places. And so that's, I think, Fluence enables providers to monetize this excess and earn whatever they feel is reasonable. And if it's too much, then they won't get any customers.
Yeah, exactly. So like if we able to connect, maximum amount of providers globally, it means that we have like a perfect competition across them globally, plus within countries, within locations, right? So we can really drive prices down as much as possible. And plus it's important to understand that the cloud, if you compare with like a big clouds, it's really like what we can do is like really 70-80% cheaper because their margins are very high. Their margins on services that they built and they invested a lot of money in, like they easily take these margins. And well, I guess the rational argument would be to say that they take these margins because they provide so many services, and we for now not provide as many services. But the thing is, the difference is their prices grow with sort of amount of services they provide, and our prices only can grow if the economics of hardware requires the hardware becomes more expensive. But essentially our economics is based purely on hardware economics. Like if it's if you're a provider and you're like buying a hardware or taking a loan to buy hardware, and then you break even like in 2 years, let's say, there is a minimum price you would be setting, and also like everyone else also have this, let's say, even access to hardware, and they also take a loans at the best rate. They also plan 2 years break even. It's still like a very low price you get out of it compared to what big clouds charge. So, and if you start building new and more services on top of it and do not add this margin, like, or maybe like, if we talk about this royalties, it will maybe like grow the price a little bit, but it's like literally percentages of the bill versus when Amazon takes it like a huge part on top. And what they do kind of rational because they have shareholders. They are for-profit companies. They want to maximize revenue. That totally makes sense. But what we try to do is different. So like the mission and the goal is different. that's why it's essentially possible here.
All of that is I think very important to understand, and I think that if you take that further, our mission and goal is to help drive sort of innovation and create open platforms to drive innovation globally through the internet, which is I think a very worthy goal. The other point about it is, being a DePIN project, people participate in this. Anyone can participate, but everyone can participate in the success of this via the token, which is, I think, a really important component here. And but before I talk about it, the one element on the DePIN side I think is worth emphasizing is that a lot of crypto, let's look at Bitcoin, started off with consumer machines mining Bitcoin basement. It's now moved to purpose-built data centers, run by public companies that are massively institutional. And you see that happen, that trajectory happen with a number of DePIN projects. It happened with Filecoin, right? Filecoin started doing storage with individuals. There's now data centers that are purpose-built Filecoin kind of miners, which are storing data. And, important, I think, mentioned on the DePIN side, Fluence has started with top-tier data center providers, and that is different from a lot of other compute providers who've started off trying to stitch together a network of more consumer grade compute, which is a more difficult problem to solve. And also, I think, encounter some skepticism from potential institutional clients. You're actually able to provide a high level of service if you are doing that. And so I think from a DePIN perspective, it's worth emphasizing where sort of the objective and sort of where we are right now with Fluence in that kind of institutional hardware area.
Yeah, yeah. Actually, like there's been a lot of experimentation and ideas in crypto in order to create a decentralized compute network. But what does it mean? It could mean very different things, and people try to connect, laptops, mobile phones, right? And sort of your fridge can earn you some dollars. There's kind of nice ideas, right? And I believe there should be some meaningful use cases in there. But if you think of like really something that can actually replace the cloud or like really compete with the cloud, you need like a proper server, enterprise grade hardware in certified data centers that with certain levels of security and data privacy protection. You need like encrypted channels, and yeah, you need reliability, you need latency, you need availability. Like it's really like data centers is actually secure, like secure buildings with fences, with armed security, and because a lot of things depend on digital services today, and data centers sort of provide you the experience of living a life. So that's different from kind of home computers and what they can offer you. um, and that's why basically, yeah. So we mainly right now partner with providers who are located in top tier data centers, and they manage the hardware properly. So they kind of like rent the space in data centers, how everyone is doing, and then they co-locate the servers, they manage them, they operate them, and a lot of them actually also came from Filecoin mining. Like they have half Filecoin servers. They also now have Fluence servers. It's all complementary, and also having your servers that provide compute close to servers that store data is very useful, because you want minimal latency when you do the like data processing in your application.
Yep, that is exactly that Filecoin ecosystem has been a big um, a big advantage to getting us a significant amount of compute right away, because you have existing kind of top tier infrastructure with excess compute, which has been a real benefit to kind of jumpstart the compute on Fluence. Let's talk about I mentioned that, token, and I think one of the great attributes of DePIN is that early providers and early people in the network can participate in the growth of the network in a way that centralized companies not possible. Like if you're an early seller on Amazon, you help attract customers to the platform. And what do you get for it? You get more competition over time. Amazon raises prices on you, and maybe you get more customers as well. But maybe Amazon even starts to compete with you, as we know they've done, right? So you don't really, maybe you just get your business gets harder. It may get a little bigger, but it may get a lot harder. But the deep inside, if you're paid in tokens, and so if the business grows, those tokens should become more valuable. It's as if you were a seller on Amazon, was paid in Amazon stock, and then was participating in that. And that is just not doable in kind of any form. And so that's, I think, one of the great kind of elements of deep in token economics. And I think, Fluence has particularly interesting token economics given the stake required to join the network. And so every CPU requires stake. And I guess, Evgeny, maybe get into a little bit about how the token economics of Fluence kind of operate, because I think it's quite different from others.
Yeah, I think like overall in terms of token economics versus like stocks, I think stocks are not cool anymore, and there's nothing cool about holding Amazon stock right now. But it's actually like pretty cool to hold tokens because you also can do something with them, right? And with the way it's designed in the Fluence network is that we have this thing called proof of capacity, which means that when providers, the idea is to basically incentivize providers to connect hardware and keep it available, even if currently it's not busy serving customers. So like when it serves customers, like customers come and pay, they pay in stable coins, providers receive stable coins, everyone is happy. But then there is some idle time of the hardware when it's not paid, or is just connected and new customers haven't yet using it. So for this, basically we did this proof of capacity. It's a sort of algorithm that providers have to run when their resources are idle. In this sense, they're proving that they have certain performance of the server, that the server is connected. They're proving like latency, and they kind of basically proving the quality of service. And for this, they get token rewards. But in order to participate in this incentivization scheme, they have to someone needs to stake Fluence tokens. And so it's designed in a way that there's a fixed amount of dollar value of Fluence tokens that needs to be staked per CPU core. Because like every servers are different, right? We have 32 core servers, 64, 96, 128, and so on and so forth. So that's why there is a sort of number protocol parameter, which is currently $200 worth of Fluence tokens, has to be staked per CPU core in order to activate the server and have it connected to a network, earn this idle like Fluence token rewards, and be able to sort of serve the customers. So this is sort of entrance. It's not a fee, but it's a kind of capital that has to be locked and associated with particular server. So like average server requires $12,000 worth of Fluence tokens to be activated. And then, it would sort of serve in a network. Sorry, I forgot.
Rewards. The rewards are also. I think you're going to go with the rewards for providing that proof of capacity.
Yeah. So rewards are currently we also have this network-wide parameter that sort of wants to have the universal flat price for the resources, and it's set as $10 per standard unit per month, and standard unit is one physical CPU core or two vCPUs. It's kind of equal thing, and 4 gigabytes of memory and like around 50 gigabytes of disk. So this is sort of like a unit, and there is a flat price of $10 for it. And then providers, they earn, like if customers pay them, they earn these $10 from customers. If their hardware is idle and runs proof of capacity, they earn this equivalent of $10 in Fluence tokens. And so that gives them, some reasonable, that also, oh yeah, important point here is that this stake, this token capital is not necessarily needs to be provided by providers, because we wanted to build this economics the way that it's easier for providers to connect. They only need to get the server. They don't need to invest additional capital to anything besides getting the hardware and operate it. So this stake can come from any token holders, like anyone who holds enough Fluence tokens can see, okay, this is new servers being connected to a network. We call them capacity commitments. So providers create capacity commitments, and anyone can stake on them. And basically by this staking, they activate the server, and then they share this FLT revenue with providers. So they earn some APR on this staking. I think currently on the network, APR is around like 11%, I think, on average. And like, of course, it's kind of, it's more stable in dollar value, but it's kind of fluctuating in FLT if you account in FLT.
And so, I mean, I think there's so many interesting things about this token economic piece, but let's go sort of reverse order. First, importantly, our view is that when you're providing cloud related services, whether it's storage or compute, stake is the way to generate trust. And there are other methods to do it, like you can have ratings and others and things, but economic incentives, we think, is the superior way to do that. Not every cloud platform currently requires stake. I think that model, though, the stake model, is the way to generate the most trust. So that's sort of point one. And that's what we've chosen to do. And I think that aligns everybody together. Then point two is that you then need to, who does that stake? And some early models require the providers to do that stake. And the problem with that is it raises costs for the providers, and they have to buy coins, which is not their core expertise, which is running hardware. And so you also then exclude the whole token holder community from participating in those economics and those transactions, which doesn't seem inclusive or fair. And so we think that you both lower costs for providers by allowing end user stake, and you involve the whole community in the ability to do that. So we think that is also a terrific way to make it as kind of as scalable as possible. And then the third bit is the dollar value link to both the stake and the rewards. And the reason it's important, the rewards, is that way providers, the institutional providers, can really count on a certain amount of revenue that they can, with some degree of certainty, think they're going to achieve. So they know if the token price goes down by half, they get twice as many FLT. They're worth the same dollar amount. Token price goes up, they get fewer FLT, but same dollar amount. So they can make long-term capital allocation decisions, which is what we think is a productive way and attracts the most institutionally oriented providers, not people who are just banking on a token, going up and are going to leave if the token goes down. That's the other point. And then finally, on the stake bit, what's cool is that if you know how many CPUs or cores you think are going to be on the Fluence network, the demand for the Fluence token in dollars. So, I think, one thing we've talked about, it's, objective of getting to one Amazon data center scale. That's 50,000 servers. That would be $600 million worth of FLT stake. That's multiples of our market cap right now, right? So, you can't do that without a lot of token demand, token buying. And so we're, years, I would think, definitely not happening. I think that's post 25, maybe 26 if things go well, we'll see those objectives, right? But that is, that just gives a sense as to which would drive both, and is required for security in the network, right? You could not have 50,000 CPUs in the network without $600 million of stake, because you wouldn't be able to secure that compute anyway, right? So this is a different model, and so we're trying to make sure people understand it, because it is, but there's a lot of great attributes to it. Did I miss anything there?
No, I think that's fair. I think I would say that, this model, what it sort of drives is this alignment of interests of all involved parties. And, this sort of flywheel of the growth, it works with, like, it sort of uh, works when there is a growth of hardware providers and the growth in terms of customer revenue, bringing like real, cash in the system, right? Because you have some providers, now you get some customers renting the capacity from providers. Now providers, basically capital, being, goes to, customers capital, customers payment goes to providers. And also because there's been a staking associated with provider hardware, the people who stake, they get their revenue, which comes in Fluence tokens. But these Fluence tokens were, received by partially splitting customer payment between provider and the staker. So now the more revenue comes from customers, basically the more sort of ability to earn here for providers and for stakers. So now there's more interest for providers to connect more hardware, and for people who can stake to kind of stake to this hardware, to more hardware. So and it's kind of circular. If there is a if Fluence is useful, right, and people want to use the platform, they bring more payments, they pay more stable coins, and this sort of revenue drives more providers and drives more token holders to stake.
Yeah, and to make that point even clearer, we could today onboard a massive amount of capacity, but we're not doing that. We're growing capacity much more in a much more deliberate way. That's going to grow obviously ahead of demand, but we think the days um, of of achieving success by showing a massive amount of capacity are kind of behind us. I think everyone recognizes that in DePIN networks, getting supply is the easy bit, and demand is really where the value is generated ultimately. And so that's what we're up to. And so, Evgeny, maybe talk about some things that are upcoming, you think, in the next kind of 2 months to Q1 in 2025.
Yeah. So we started Fluence with the serverless, right? So and our serverless, as we call, like a cloud functions, cloudless functions, which is alternative to cloud functions. And our cloud functions are WebAssembly based, and this is like relatively narrow use case of the whole cloud. Like cloud can provide very different things in a very different sort of packaging the compute consumption in very different ways. So now we actually adding the new, more universal way to consume compute, which is virtual machines, which is analogy to Amazon EC2 or VPS or DigitalOcean droplets, like a basic compute unit that you can use universally, can deploy any kind of workload in it, and can run anything there, basically. So you're not limited by this serverless and function paradigm. You can, basically have a piece of real server allocated for you, and then you can utilize it the way you want. So we are launching virtual machines in for alpha testers by the end of December. This is our current prediction. And we right now already have sort of alpha. You can apply to be the first to try. We have the form on the website. We have the blog post just published yesterday, I think. So if you're interested, please go to blog at Fluence Network and see the details of the program and fill the application. And we'll be rolling it for first customers over the next few weeks and a couple of months. And this is, we believe that actually this will enable a bunch of use cases for Fluence and for it to be used by multiple customers. And this is CPU only VMs, right? But then actually also we are working on GPUs in parallel, because GPU VMs are the same as CPU VMs, but on the hardware that have GPUs. So like it's only different physical server you need in order to make it work. So because we have these multiple providers globally, they keep asking us like when they can connect the GPUs to our network, and they have these GPUs. So we obviously working towards enabling this for customers as well, like connecting this GPU service and providing them on the platform for customers. So it's gonna be CPU VMs that we are launching soon, GPU VMs that are a little later. We are exploring containers, because container is kind of similar thing, but it's a little different way of deploying applications to the cloud. So containers definitely on the roadmap. We are looking at clusters ability, like fault tolerance, like cross data centers fault tolerance, all this stuff. So with VMs, it just opens us a lot of flexibility and a lot of opportunity to deliver different kind of cloud services. And all we're talking is open source, right? All we're talking is open, and whenever it's delivered, we would also try to push people and like talk about it, right? And push people try building also their cloud services on top of this, right? So try building some experiences for customers using this low-level infrastructure, and have their own customer sets, have their own like a go-to-market strategy, but utilizing under the hood this this network of providers and this basic orchestration of workloads and virtualization of workloads.
Well, listen, it's really exciting. I mean, Fluence was founded in 2017. It's been a lot of development. The network is live now. Staking is live. Machines are on the network. Rewards are being paid. I think we'll announce customers the next month or so, and then with the enhancements and products and technology developments that Evgeny's mentioned, it will just sort of increase the scope of what we can address, which is terrific. And so I think 2025 is going to be a very big year for Fluence and for demonstrating what we can do and starting to scale it. So very excited about that. Evgeny, you want to tell people how to follow Fluence, how to stake? Give us some key things here.
Yeah, sure. Actually, one more point on I think on the customer base. We right now with these VMs and like the serverless, essentially like this is a Web3 product. The VMs, we start from Web3 customers, but if you think of the cloud, like if you think of Web3 in terms of the cloud and compute consumption, Web3 is a small market compared to the whole big cloud, right? So that's why we actually have a multiple directions of multiple segments of customers we are targeting in Web2, and we really want to people who are, well, they don't call themselves Web2, like they just are like enterprises, SMBs, startups that using the cloud infrastructure. But we really want to build a product that is like really competes with the traditional cloud and is able to onboard these people. And we're really targeting Web2 companies to get them to this new Web3 infrastructure. Yeah, so I just want to make it clear that we are not we are not charging customers in tokens, right? So we are not limiting ourselves in Web3, because we understand that cloud is something that is necessary for humanity. There is like a huge demand outside of Web3 ecosystem, and we are building product here for the as a tech product overall, not just a Web3 segment of it. Yeah, and if people want to find more information, there is a Fluence.network as a main website. We have a Twitter. It's Fluence_project. We have a Telegram group, a Telegram channel with announcements, and the last information about the virtual machines is in our blog. And also we have YouTube, actually, where some of recordings of our last talks is published, where we also have slides and visual presentations about how Fluence works and what's coming.
Awesome. Well, listen, great to have you on, Evgeny, and
Thank you.
glad we finally did this, and I hope everyone here understands everything we talked about in Fluence and follows us and joins the community and stays in touch and sees what we have in store for 2025, because it is going to be exciting. So stay tuned, everybody, and thanks for listening.